All right. In a little bit, I'm going to tell you why we are learning this, but today we're going to discuss the rational exponent property. This property states that if I have a radical, I have my exponent here and my index there. I can rewrite that as x a over b, or write them out as a fraction. My exponent goes on top and my index goes below. So, if I was going to take this one, I would end up with 3 exponent over index. And then I could solve it. Because that's a real number, I can get a real number as my answer. For this one, I would say y, if there's no number there, my exponent is an understood 1. If I have an understood index, it's a 2. Then for this one, another kind of a harder step, if I have this, I'm going to do it for each individual coefficient. My 3 has an invisible 1 and an understood 2. Y has my exponent and an understood 2. Now, why are we learning this rational exponent property? Because we have tried some problems in the past, and we have been told we could not do them. An example, you have been given the third root of y squared times the square root of y, and we'll just say y. Well, before I said that's all you can do. You can't solve it anymore. Well, what we're going to do now is find a way to solve it. What we can do is take each of these problems and write them out as a fraction. So I have y a over b times y a over b. Now, what we're going to do is what we've done before. If I have x squared times x to the third, my answer is not x6, my answer is x to the fifth. We really are adding exponents. So we're going to add our fractions. And you've been adding fractions forever. The method you're used to is common denominator. So off to the side, let's get our common denominator and add them together. 7 over 6 is my answer. That's basically what my answer is here. Y is the value I'm combining, 7 over 6. Now notice I didn't do like a 2y. I got 7 over 6. And now we're just going to take it back to my original form. So my answer, sorry, my work kind of got in the way, is over an index. Now if I can simplify anything, please do that. Like for this one, I have a group of 6 inside there. So my group gets pulled out, my leftover y, and my index. And then I really am done. So my steps were, 1, write it as a fraction. 2, add or subtract. We'll talk about subtraction in a second. Then rewrite it as a radical. And then simplify. So we didn't do anything hard. You can see kind of the amount of space it might take up though. We're going to be told to multiply, so we write it as a fraction. Add our fractions together, rewrite it as a radical, and then simplify if possible. So let's try another example. If they gave us a problem that looked like x, we'll do a fifth root and it's squared, times x to the fourth root, or the fourth root of x. Okay, you try to solve the problem on your own, or at least try to write out the first step. The first step would look like 2 over 5 times 1 over 4. Now what do? Add your fractions together. Get your common denominator. Put them together. Now, turn it into a radical. This was the value x in front. So, I have x, 13, 20. Can I simplify? Are there any groups of 20 in here? There aren't. So, I don't have to simplify. I am done. Now, I did say with my steps that I could subtract. Well, how do we know when to subtract? Whenever there is either a negative sign in my exponents, you will subtract, or if there is a denominator. Basically, if you do any division, you will be doing a subtraction problem. So, if they gave me an issue that looked like the third root of x over the fourth root of x, we could go the long way, which would be multiplying by the amount that I still need, which is 3. Do it on the top. Now this is gone. I'm ending up with x in the denominator. Oh my goodness. I would have to do the steps I just did up here. Not impossible, but there's a shortcut. So what we're going to do is take the cubed root of x, the fourth root of x, and we are going to turn them into the fractions. So this gives me x and 1/3. This gives me x and 1/4. Because it's in the denominator, we are going to subtract them. So I can still consider this a multiplication problem, but I'm going to instead subtract the bottom one. So this gives me, well, I guess I have to actually work it out. 1/3, 1/4. My common denominator is 12, 4, and 3. Sorry. That gives me 1/12 at the end. And it is still positive. Remember, this was my positive value, that was my negative. If I had received a negative 12, that just means that I would put whatever my answer is over 1. That's inversing idea. So here, my answer is x 1/12. So I have x here and my 12 there, invisible 1. And that is our answer. So we subtracted when I had a denominator or a negative right up here. That should be enough for you guys to get started on your assignment for tonight. I will show you again your steps. You turn them into fractions if they're not already, then subtract or add, turn them into radicals, and simplify if possible.